All right, what I'm doing right now is an explanation for this pre-quiz warm-up number 2. If you just want to check your answer, you can go to the backboard or the key on Canvas. This is more for you need a verbal explanation as to why the answer is what it is. So question number 1, I know that I can't have a root in the bottom, so I'm going to do this process called rationalizing the denominator. The way to get the root out of the bottom is to multiply it by whatever in the bottom. So for this one, I'm going to multiply the top and bottom by the square root of 2. So I've got square root of 2. On the top, I can combine 16 and root 2 to make that root 32 because one's a root and one's not. So I'll just write that as 16 root 2. On the bottom, root 2 times root 2 is root 4. You can skip that step and just call it a 2 because the square root of 4 is just 2. Right? I'm writing it out so you can see it all. And then my last step here is going to be to simplify my like terms. 16 and 2 are both not inside the root, which makes them like terms. So 16 divided by 2 is 8. So my final answer for this one is 8 root 2. The denominator is rationalized because there's no root in the bottom anymore. If I want to get rid of the root in the bottom for one like number 2, I have to multiply the bottom by what's called its conjugate. Conjugates, we keep the numbers the same. We just change the symbol. So the conjugate of 1 plus root 6 is 1 minus root 6. And I've got to do that to the top and the bottom. So I'm multiplying them both by 1 minus root 6. So in the top, I'm going to distribute the 4. So I'll do 4 times 1. And 4 times root 6 is just 4 root 6. I can't combine them because they're not like terms. They're not in the same format. In the bottom, I'll do 1 times 1. 1 times root minus root 6 is like 1 minus root 6. Root 6 times 1. And root 6 times root 6 would be a minus root 36. From here, I can see that these terms cancel out. And they should. When you're multiplying by a conjugate, those middle terms should cancel out. So I'm left with 4 minus 4 root 6 over 1 minus 6 because the square root of 36 is just 6. So 4 minus 4 root 6 over negative 5. If the numbers outside the root had common factors, like let's say the bottom was negative 2, I would simplify by reducing those numbers, but in this case, there are no like terms. So I'm just going to leave it like this. All right, for the next one, I'm going to start with what I know. I know that I have 900 degrees per second. Make sure you label these conversion problems because the labels are the key. What I want is for the degrees to become revolutions and the seconds to become minutes. I know that because the degrees are in the top and the revolutions are in the top and the seconds are in the bottom and the minutes are in the bottom. So that kind of tells you what the conversions are going to be. So seconds to minutes is a really easy conversion. I'm going to convert using the fact that I know that 1 minute is 60 seconds. Because I want the seconds to cancel out, I'm going to put the seconds in the opposite place. So you'll see this, if the seconds is on the bottom of the given, it should go on the top of your ratio. And I know that 1 minute is 60 seconds. So I want to make sure those appropriate units go next to the numbers go next to the appropriate unit. What this is going to do is cancel out the seconds, and it's going to leave me with degrees per minute. But I want revolutions per minute. So I want to get rid of the degrees, which means I have to have some sort of degree on the bottom. And what I want to stay is revolutions, so I'll put that on the top. So what I need to figure out is what's the ratio for revolutions and degrees. Well, 1 revolution is a full circle, which is 360 degrees. All right, and what this is going to do is it's going to cancel out the degrees, and it's just going to leave me with revolutions on top, and the only unit left on the bottom is minutes. And that's what I want. I want revolutions per minute. So from here, what I'm going to do is multiply straight across the top. 900 times 60 times 1 is 54,000. And I'm gonna go straight across the bottom. 1 times 360 is 360. And then the last thing I'm gonna do is take that numerator number, 54,000, and divide it by 360. And that's 150 revolutions per minute. The key to these problems are writing your units down, right? And putting units in opposite places to make it cancel out. Okay, last one here. A tire has a radius of 8 inches and it's traveling at 65 miles per hour. Find the speed in revolutions per minute. Well, the first thing that we have to take into account is there's 2 pieces of information here. And so when you're given a radius, you want to use that to find the circumference, because the circumference is similar to a revolution in that it goes around. So the circumference is 2 pi r. So 2 pi, and then in this case, r is 8. And I can combine that 8 and 2 and call it a 16 pi. And the label on that is inches. So I'm eventually going to use that. And I know that a circumference is a full circle and a revolution is a full circle. So basically, 1 full revolution is going to be 16 pi inches, equivalent to the circumference. So I'm eventually going to use that information. I'm also going to use that 1 mile equals 5,280 feet. All right, so let's start with what we know. We know that we've got 65 miles per hour. That's my given information. I want the miles to become revolutions and the minutes to become, the miles to become revolution and the hours to become minutes. So I'm going to do hours and minutes first. That's the easiest one. So if I want the hours to go away, I need to put it on the opposite place, and the minutes is going to stay, so I'm going to put that here. And then I need to use what I know. I know that 1 hour is 60 minutes. So make sure the numbers are next to the correct units. 1 hour is equal to 60 minutes. What this is going to do is cancel out the hours, and it's giving me miles per minute, which is good. I've got the minutes, but now I need the revolutions. So the next thing I want to do is I want to get rid of the miles. So I have to use some information I know to get rid of the miles. I don't know how many revolutions are in a mile, but I know how many feet are in a mile. That's given to me, so that's got to be some sort of information I'm using. So 1 mile is 5,280 feet. Okay, that's going to get rid of miles, and it's going to leave me with feet per minute. Still not what I want. I want revolutions per minute. So I got to get rid of feet. And I want it to become revolutions, but I don't know how many feet are in a revolution. What I do know is how many inches are in a foot. So I can change it to inches, which is getting us closer to the revolutions, because the revolutions are in terms of inches. So I know that 1 foot is 12 inches, and this is going to cancel out feet. And now I have inches per minute, so I'm getting closer. Now, if I want to get rid of the inches, I do have something in terms of inches. I have 16 pi inches are equal to 1 revolution. And now I get rid of inches and I've got revolutions on top. So now my final units are revolutions per minute, which is what I want. So now I just have to do some multiplication. I'm going to do the top numbers. 65 times 5,280 times 12 times 1. I'm going to have this really big number. And the label on that big number is revolutions. It's the only unit that's not crossed out in the top. And on the bottom, I'm going to do 60 times 16 times pi. And I'm going to get this number on the bottom. You can round it if you want. I'm going to write it all out. And the only label left on the bottom is minutes. So revs per minute. And then my final step is going to be to take that top number and divide it by the bottom number to get a final single number of 1365. And then I'm going to label or round that to 0.55. And the label on that would be revolutions per minute. Those are tough. You got to work your way through the units and just make sure you're putting units in opposite places.